Welcome, this is section 4.6. Just kidding, 4.6. We're talking about how do we graph a line in slope-intercept form. So slope-intercept form looks like this, where the number being multiplied with x is the slope. You can think of that as movement because slope is rise divided by run. And b is where we begin, that's the y-intercept. That's the when x is 0, what is y? So that would be our b value right there. We plot that. The y-intercept is the location that the graph crosses, or the line crosses, the y-axis. So let's try this. So I'm going to skip down to here. So here's our process. How do I graph a line in slope-intercept form? First of all, the equation must be in slope-intercept form, which looks like this. Then we're going to plot the y-intercept, which we referred to as b, to where we begin. And then from the y-intercept, we use the slope fraction to make the next point by counting, well, we look at the top number, and if it's positive, we're going to go up. If it's negative, we're going to go down. And then we don't make a point. Once we go up or down, we don't put a point there. We then need to move right whatever the bottom number is, or the denominator. And we're going to repeat that movement that we just did in step number 3 over and over. So we're going to get more points from the slope. That is how we move to make a line, to get that series of points. And a line is really just a series of continuous points going on forever and ever. At the end, we put arrows on it. So let's try this. I wonder if I can reposition things a little bit. Nope, it's all connected. Wonder if that helped at all besides making things look a little goofy. There, we'll call that pretty good. So, example number 1 is in slope-intercept form. That's awesome. So what is the y-intercept? That's our first step. That's step number 2. But that's our first action step once it's in slope-intercept form. So the y-intercept is 1. So on the y-axis, we go to positive 1, which is right there. From the y-intercept, we're going to use the slope fraction. Oh, whoa, this is the slope, because slope is the value that's being multiplied with x, which in this case is a 2. So that's slope. It says use the slope fraction. Well, the slope is 2. How do I make that into a fraction? If there is no number in the denominator, it is a 1. 2 divided by 1 is the same as 2. Why do we make it into a fraction? Because it's actually nice to graph slopes with a fraction, because the top number tells me how much I'm going up or down. In this case, I'm going up 2 because it's a positive 2. The bottom number tells me how much I'm moving. I'm moving 1 to the right, and that's really important to move that 1 to the right. It's as important as any other number. So from the y-intercept, from right here, this first red dot that I plotted, I'm going to go up 2 and right 1, and then I make a point. Up 2, right 1, and then I make a point. Up 2, right 1, and then I make a point. I've never done it that way before with the song. I kind of like that. And there's part of the line, but guess what, folks? It goes the other way too. It's like a mountain that keeps on going forever and ever. And to do the other direction, you don't need to do different colors like I'm about to do, but we would then go down 2 and left 1. Down 2, left 1. Down 2 and left 1. Down 2 and left 1. See how these points are all collinear? They're all part of the same line. Boom. Don't need to color code it like this at all, folks, but that's how we did that. I'm going to even make the dots bigger just so you can see them, but you do not need to do that either as you make your line. There we are. Let's try another one. Example number 2 is in slope-intercept form. So our y-intercept is the constant. It's the number that's being added or subtracted to the x. X is being added to by 2. So the y-intercept is a positive 2. So on the y-axis, I go to positive 2. That's right there now. And then from that y-intercept, I use the slope fraction. Well, let's see, slope is the number being multiplied with x, and it's negative 3. It's supposed to be a fraction, and since it's not a fraction, I say that it's negative 3 divided by 1. Because the top number is a negative, that means I'm actually going to go down 3 as I go right 1. to the right 1. So from the y-intercept, down 3, right 1. Down 3, right 1, down 3, right 1. That doesn't fit. I could extend the graph or just leave it. And then to get more points, I can go up 3, but then I have to go left 1. See how this next green dot, when I go from the y-intercept up 3, left 1, it makes a straight line with all the other ones. And it's nice to have a bunch of dots on here. That way, as we sketch our line, it makes it easier to sketch a little more accurate of a line. Again, your lines, as we talked about before, don't have to be perfectly straight. That's good enough. I see the dots, so I see that, or the points on the line. I see that whoever graphed this, Mr. Bishke, knows where the line should be. I just know that I don't have the straightest, surest hand in the world, and that's okay. But make your dots visible. Maybe a little too visible over there, so you don't have to spend an hour making nice dots. Here's a couple fun ones. This is a little bit different than slope-intercept form, right? Right, that slope-intercept form. So like you might be thinking, well, the y-intercept's -8. Well, no, it's -8 divided by 2. And you might be thinking the slope is 4. Well, it's 4 divided by 2. So we needed to simplify this into slope-intercept form. So we'll rewrite this as, well, 4x divided by 2 is 2x. And -8 divided by 4 is, -8 divided by 2 is -4. So now it's in slope-intercept form. Now I accurately know that the y-intercept is -4. So on the y-axis, go to -4. Well, that's down here. And then from there we need to plot our slope. So our slope is 2, which is the same as 2 divided by 1. So up 2, right 1. Oops. Wow, that was funny. I accidentally put that dot on there. I didn't actually count it out. So from the y-intercept, up 2, right 1. Up 2, right 1. Keep on going. You know that song I made up for the first example? I don't even remember what it was. It was that unique and in the moment. I'm going to have to go back and figure out how to sing that for class. Down 2, left 1, right? Because we reverse, or correct, because we reverse the direction of the arrows on the top and the bottom. Both movements. So now it's down 2, left 1, down 2, left 1. Zing your line, and I don't think I explicitly said this, please put arrows on the end of your lines. Gotta have arrows because it keeps going forever and ever, and we don't want to sit there for the rest of our life making dots and extending graph paper. So just put an arrow on it and tell me that you know that it goes forever and ever. Example number 4, I made a little boo-boo here. Let's put an x in there. I think it's supposed to be -6x plus 12, all divided by 4. So what's the y-intercept? It's not 12, it's 12 divided by 4, which is 3. What's the slope? Well, it's not -6, it's -6 divided by 4. So -6 divided by 4, which is equivalent to -3 divided by 2. So let's plot our y-intercept. The y-intercept is +3, so on the y-axis we go there. And now we're going to move down 6, right 4, or down 3, right 2. Down 3, right 2. Down 3, right 2. Down 3, right 2. Can I get more points on here? Yes. Go up 3, left 2. Up 3, left 2. Up 3, left. Right about there. Zing your line. Put some arrows on. Yeehaw! Let's see here. So you're going to have some practice with that in a little bit. A way that you can check your lines is by using Desmos. So www.desmos.com, start graphing. And so say in example number 1, I need to graph that line. Now I want you to graph it. I want you to do your best, use your notes, and try to graph the line correctly. I want you to do that thinking. This is about thinking about a process. And then I want you to check. And if you make a mistake, that's okay. Then just go fix it. But to use what I'm about to show you to graph all the lines and not learn anything, just to copy things, it's not going to give you. You might as well please don't do it. It's not going to help you at all. we're going to have to go back and say, hey, where's the practice? How did you learn how to do this? How did you figure this out? And so if you don't put the thought process in, you're not getting anything out of it. You're actually just wasting your time. But if you try it, you think through it, then you can check it this way. And if you make a mistake, think about how that mistake happened and learn from it. And that's the process for learning. You got to put that effort in and then check it so you get that feedback. Here's a good feedback tool. We'll use this in other ways too. So anyway, there's my long lecture. So on the Desmos, you had to start graphing. And now we're typing a fraction. So 2 divided by 5. I actually just hit the backslash bar, like the question mark. It's on the question mark button, but don't hit shift. And it makes the fraction. So I typed a 5, and now I arrowed to the right. So when you arrow to the left, you get in the fraction. When you get arrow to the right here, you get out of it. And then x. So that's 2/5 x, and then minus 3. Ooh, see, that drops it down. So the y-intercept is -3, and then they're going up to right 5. And then you can use your trackpad, or whatever they call that. You can push down, so click and hold, and then you can use your other finger to drag it all around. You can do like a 2-finger zoom. You can do a 2-finger zoom out. All that cool stuff. So hopefully, as you did number 1, and you graphed it, hopefully now their scaling is a little bit different, but is your y-intercept at -3? Theirs is. Is yours? Yeah, good. Did they go up 2 and right 5? So that's going to be kind of tough to see, perhaps. Maybe you need to zoom in or something. But, yeah. So they went up 2 and right 5 to make that point right there. It should match one of the points on your line. You can go back and check some others if you'd like to. Common mistakes are having an incorrect slope. Like this is a positive slope. Some people might accidentally have their line going down in a negative slope fashion. Sometimes their y-intercepts are wrong. If you just count wrong, if you accidentally went up 2 and right 6 just because you're counting mistake, that's not the biggest deal in the world. On a test, try to double check things. But so we just covered graphing lines in slope-intercept form. It's a pretty sweet equation because we can graph a line very quickly. It's a lot quicker than making a table, right? And plotting all those little individual points off of the table. Now we can just kind of get that y-intercept on there and then put a bunch of different lines from there using the slope, or different points using the slope, and it's really quick and easy. Slope-intercept form, oh yeah, y = mx + b.